Hello everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire and today we've got Vommseedhar who has just completed the course Linux Basics for Robotics, and he'll be giving us a presentation on that. So let me now hand over the platform to him so that he can begin his presentation. Alright, whenever you're ready.
Yes, sir.
Okay, you can connect Vommseedhar. Alright, can you be explaining what you'll be doing as you progress?
Okay. Yes. Sir, so now I am basically connecting the robot. So first I have run the bring up program to connect the robot. Now I will launch the interface program. So for that, now I will be running my obstacle avoidance program. So here the robot is calculating the parameters. Once I will now run the static code. So, sir, as we can see, the robot is calculating the distance it is measuring using the sensors. So now, yes, the robot will move forward, and here in the window, we can see the parameters that robot is actually calculating. So now, as the left range is more, though the robot will turn left.
Alright.
Now, as we can see, the left is more. So again, the front left is more. So it will turn left. Now, as there is nothing in front of the robot and it has distance, so it will move forward.
Alright.
Now as the right range is more, so the robot will turn right.
Alright, I think we've seen that it manages to avoid obstacles. Can you now open the code editor and you show us your code?
Oh, sir, should I stop the robot?
Yes, please.
Yes, sir. So here is the code for the obstacle avoidance. So, sir, the first line is the shebang line. It basically tells the file that it is a bash script. And then the next line is the source robot function line. So it basically includes the function library,
Mm-hmm.
which is there in another file.
Mm-hmm. Okay.
So now here we can see the echo running naive obstacle avoider with basic script. So this actually, it is basically the print statement. It just prints the line on the terminal. Now, firstly, we have set the linear velocity and the angular velocity of the robot to 0. Then afterwards, I have set a threshold value of 0.3. And then here is the while loop. So the robot will continuously run the statements which are there in this while loop.
Mm-hmm.
So so the first line is left range. Left range is actually, so it actually gives the left side values of the robot. So here now the next line is echo. So it basically prints the value which the robot is calculating. So similarly, front left, front right, right. Now here is the another line which is front left free. This basically checks whether the front left range is greater than the threshold value which we have set. Then the echo line prints the front left value. So the output of the front left free or front free or front right free is 0 or 1. If this statement is true, then it will print 1, and if it is false, then it will print 0. So yes, so in the first line of the program, the robot checks the whether the front left is not, if the we have 8 conditions, we have put 8 conditions for the robot. So the in the first condition is the front is that where none of the ranges are free. So it basically it first checks if whether if FL is equal to free is equal to 0. So this tells if it is not free, then it checks is it free or not. Uh, then we have then we have another statement in this. If left range is greater than right range, then it will turn left, and if it is false, then it will turn right. And then we have put the sleep timer. So after 1.5 seconds, the robot will stop. So after rotating 0.3146 at a speed of 0.3146 radians per second, the robot will stop after 1.5 seconds. And then we have again set the angular velocity to 0. So then we have one more statement. So in that statement, it tells the condition, it checks the condition where the robot, if the left is not free and the front is not free and the front right is not free, then it tells the robot what to do. So first, so here is the line for that. Then after that, if it is true, then it will then it will turn right at a speed of 0.31416 radians per second, and after 1.5 seconds it will stop. Now again we have one more condition. So it checks that whether the front left is not free. So it tells the robot what to do if front left is not free and front is free and front right is not free. So here the it tells if this condition is true, then the robot will basically move forward. So the distance it will move forward is f range minus the front range which it calculates, minus the threshold value which we have set, that is 0.3.
Okay, all right. Let's move on to the statistics-based script now, so that we can see what you did in there.
Sir, sorry, sir.
All right. Can you move on to this robot statistics script?
Okay, sir.
Yes.
So, sir, here we have set all the parameters of the robot. Actually, this line is it actually it gets the value from the robot sensors. So the first line is the shebang line. It basically again tells the file that it is a bash script. Then here is the source file. So in the source file, we have actually included the function libraries which are provided in the robot functions.
Okay.
Now then again two echo lines are print lines are there which just prints the statement. Now here is the while loop which again goes on calculating the values. So the first is odom distance, start distance. It basically calculates the distance from where it when the robot starts till the part of the robot where we want to calculate the robot. It actually calculates the distance. So it now the next line is current direction. This basically tells the direction of the robot, current direction of the robot. Now this and now is the odom underscore x. It actually tells us the x direction of the robot, x position of the robot. Now similarly, it goes for x, y, and z. Now here is the orientation program. So it basically calculates the raw raw pitch and roll of the robot. So here this basically returns the yaw pitch and roll of the robot.
All right.
Now here
all right.
is the okay.
Yeah, go ahead. You can finish the last bit.
Okay. So here these three lines are for angular velocities of the XYZ. It returns the angular velocity of the X direction, of the Y direction, of the and the Z direction.
All right. All right.
And here is the these three lines are for linear acceleration of X, Y, and Z direction of the robot.
All right. All right. Thank you so much. Now let's get into a couple of questions, right? So, can you
Okay,
show
sir.
me how you open from one directory to the other? So what I would want you to do is to open your terminal and then you navigate from the home
Okay,
directory
sir.
to, let's say, where you have your Python and Bash scripts.
So first, okay. If
Okay, maximize that so that we can see exactly what you're doing.
okay, okay.
So let's say go to the folder that has your
So sir,
your
first I will go into this folder, SRC folder, which is there in the ROS2 underscore workshop folder. So from now, if I have to navigate to another folder, that is Linux underscore basics dot project. So I will go in this. Is the what is it? Okay, okay. So it's my bad. Actually, the file name is. So, sir, actually, I have navigated into Linux basics underscore project.
And if you're going to
No.
list all the files that are in that folder, how do you do it?
So all the files that are there in the folder. So Linux underscore basics underscore project. It is a folder basically. So
Okay.
and this package.xml resources setup.cfg setup.py. So
Now
yes.
open that folder, the Linux Basics project folder again. Okay, list the contents. Now I want you to change the permission. So first of all, let's do a listing of all the permissions that those files have got. So let's take, for example, the obstacle avoider. Can you list the permissions for that?
So, sir, for obstacle avoider, the permissions are all permissions are there, the write, the read, and the execute permission.
All right. Now let's say you wanted to remove the execution criteria on that file. How would you do it?
Okay, sir. Now again, I will show the permission.
All right.
So, sir, we can see that I have removed the executing permissions of robot obstacle avoid.
All right.
Obstacle avoider.
All right, wonderful. Thank you so much. Okay, on to the next question. Can you give me the 3 groups that you have got within the Linux system, right?
So, owner, group,
Mm-hmm.
and all.
No,
All users. Owner, group, and all users.
that's 2. There should be 3.
So, sir, can I refer my notes?
So owner, user, and owner, that's you, the user, right? And
Yes.
then you have got the
And the group.
yes, and then you've got all others, right?
Yeah. Yes, sir.
All right.
Yes.
All right. Let's go to the next one. So, can you give me a brief explanation of what are environmental variables within the Linux shell?
Environment variables.
Mm-hmm.
So basically, environment.
Like in the least amount of words, what do you understand
Yes.
by the term environmental variables? Yes.
Yes, sir. Actually, I don't remember it.
All right. So we'll let it go for now. But that's some homework for you to do. All right. So
Yes,
thank you very
sir.
much for your presentation. I wish you all the best on the coming ones. So just hang on as we wrap it up. Okay. All right, everyone. This was Vodman's presentation, and would like to congratulate him for a job well done, and also getting us to understand what he did and some of the basics of Linux that are quite paramount for everyone to know. And until next time, we'd like to encourage all those of you to keep pushing your ROS learning. Bye bye.